So, today we are very happy and honored to have as the colloquium speaker Professor Peter Ulmschneider from the University of Heidelberg. Peter is a well-known scientist in two areas of astrophysics. One is the area of solar and stellar atmospheres. In fact, the first time we met was a long time ago at Harvard, when Peter was a visiting professor then at Harvard, and I was there, and working on stellar astrophysics. And then the second subject where Peter works is astrobiology. This is the area which has to do with this subject Peter is talking to us today. The subject is very popular, of course. Everybody is interested to know about the prospects of having contact with some extraterrestrial civilization. Talking in the newscast last week was saying that it would be maybe a disaster if we ever guess it. We don't know if it's positive or negative, but it would be the greatest evolution in our society. In any case, Peter also has written a book for Springer, Intelligent Life in the Universe. So he has worked a lot on this subject as well. The other thing I want to say is that this semester, Professor Ulmschneider is giving a course for the graduate students, not only of the astrophysics group, but graduate students who come from other sections on this topic. And we are really obliged to see that Peter came from Heidelberg to teach us here the latest news on this subject. It's very kind of him to be with us for this month and give us these lectures. So we thank him very much for giving this series of lectures to the graduate students and for telling us in 1 hour the resume of the course, I guess, yes, today. So, Peter, you have the floor, and thank you very much for teaching us here and for coming to the university. It is our pleasure, and we really appreciate it.
Well, thank you very much for this very kind introduction, and I must say that I am really utterly honored to be able to speak and give a lecture at this famous place, Athens, where luminaries like Plato and Aristotle gave their lectures. So I feel very small in this wonderful place. Unfortunately, I'm not a great expert in the computer details, so you have to suffer this type of display. I want to talk to you about intelligent life in the universe, myth or reality. It has been known, man has always believed that there are intelligent non-human beings around. Gods, angels, demons, centaurs, UFOs, and so on. What does science say about this? Unfortunately, we have to tell that no contact with extraterrestrials has ever been established, no trace of their existence has ever been found. But if you ask somebody, a colleague in astrophysics, he will tell you that it's practically certain that extraterrestrial intelligent civilizations exist. There is only a debate how many of them exist. This is the big debate. The reason why you can be so certain is based on 3 arguments for the existence of extraterrestrial intelligent civilizations. One is the so-called astronomical argument, which tells you that there is a very large number of Earth-like planets in the universe. And the second argument is, once you have an Earth-like planet, it is extremely certain, almost certain, that life and also intelligent life develops on it. Now, if you take these two arguments together, then you have the conclusion that there are many extraterrestrial civilizations, and the problem is now, why don't we have contact? This is a big problem. This is called Fermi paradox. And an argument I'm going to give you is, you can get an answer to this question if you think more carefully about the nature of extraterrestrial intelligent beings. Let me now first show you this mean annual isotherms on Earth, this map, and you see the Sahara here in red, where the temperatures are above 25 centigrades annually over the whole year, and there is very little life in this area, both human or plant or animals. Also in the Arctic, where the mean annual temperatures are below 0 degrees centigrade, you have practically no life. And this tells you that life lives only in a certain zone of temperatures, and the temperature can vary at most because the temperatures are derived from the soul, from the sun. Without the sun we would not have life. The solar radiation flux, and the solar radiation flux from the Sahara to the Arctic varies at most by a factor of 2, because cosine 60 degrees is 1/2. So now we ask the question, or make a thought experiment. Let's say here is the Earth. How far can you bring the Earth closer to the sun and still have life on it? As the radiation flux goes as 1 over the square root of the distance, you can go to 0.7 astronomical units, and then you have this factor of 2, in which case the Sahara would expand to all the way to the Arctic. And you could move the Earth away to a distance of 1.4 astronomical units. In this case, then the Arctic would move down to the equator, and this region, being a factor of 2 in radius and a factor of 4 in luminosity or flux, is the so-called habitable zone. Then let us assume, where is this in the solar system? You find it happens roughly to be the distance between a Venus orbit and the Mars orbit. Here is radii of these orbits. This is the habitable zone. In reality, you want to have such a habitable zone, and you have a planet in here for all the time that life is on Earth, 4 billion years. And as the sun is increasing in luminosity constantly, this habitable zone changes, and also there are instabilities of the atmosphere of the Earth, and that means the real habitable zone is much smaller. It is a small strip of 0.95 to 1.01 astronomical units around the Earth's orbit.